Welcome again in the course of Basic of Calculus. In previous video, we have learned about functions. In this video, we are going to plot those functions in Cartesian coordinate. Plotting the graph of a function is just a pictorial representation or visualization of that function. To plot single variable function fx, we need two axes. X-axis for representation of inputs of the function and y-axis for representation of output for the corresponding values of x. Let's take some examples. Y equals to x. Let's plot the corresponding values of y for each value of x. Say at x is equal to 1, y equals to 1, at x is equal to 1.5, y equals to 1.5, and x is equal to 3, y equals to 3. If we join these points, we will get the graph of the function y equals to x, which is a straight line passing through origin. So, this graph is made up of the points on the xy plane whose coordinates satisfy the rule y equals to x. For this function, the domain is every possible values of x, which is set of all real numbers, and range is the corresponding values of y for x, which is again set of all real numbers in this case. Now, if we plot the graph of the function fx equals to x square, the graph will look like this. And for this function, graph is made up of the points on the xy plane whose coordinates satisfy the rule y equals to x square. Similarly, all functions can be represented as a graph in Cartesian coordinate. Let's draw the graph of equation y square equals to x, or y equals to plus minus under root x, of which we have discussed in previous video. If we analyze the graph, we can see that for one value of x, there are two values of y, which is against the definition of function. So, y equals to plus minus under root x can't said to be a function, of which we have already discussed in previous video. To find out whether the given equation is a function or not, see if there are two or more values of y for single value of x. If yes, then the equation is not a function. This can be seen easily with the help of graph. If we take the graph of the same equation y square equals to x and draw a vertical line, we can see that there are two values of y for single value of x. So it is not a function. So to find out whether the given equation is a function or not, draw a vertical line passing through the graph of the equation. If the line cuts the graph at two or more points, the given equation can't be a function. Now we are going to plot the graph of two variables function z equals to f of x of y. For this, we need x-axis for representing the values of independent variable x, y-axis for representing the values of independent variable y, and z-axis for representing the values of dependent variable z. Let's take an example z equals to x square plus y square. For each set of values of x and y, there is unique value of z. So, for two variable function, domain consists the coordinates of the xy plane, and range consists the height or the values at the z-axis for that point on xy plane. So for the function fx is equal to x square plus y square, at x comma y equals to 1 comma 1, the value of z is 2. And its representation on 3D Cartesian coordinate is this. Thus, the coordinate of this point is given as 1 comma 1 comma 2. Similarly, some other values of z for other domains are listed in this table as shown, and they are plotted in the graph as shown. If we take all possible sets of points on xy plane, the plot of the graph is look like this. This is the three-dimensional plot of the two-variable function z equals to x square plus y square. Similarly, other functions can be plotted. Here are a few examples. But what about plotting the function of more than two variables? For functions with one variable, we need two-dimensional Cartesian coordinate. For function with two variables, we need three-dimensional Cartesian coordinate. And for function with 3 variables, we need 4-dimensional Cartesian coordinates. Similarly, for n variable function, we need n plus 1 Cartesian coordinate system. But our brain does not allow us to imagine things in more than 3 dimensions. So, we can't plot the graph of more than 2 variable function. This is all about the basic of plotting the graph of functions. Now, we are ready to stay forward to understand the basic of calculus. In the next video, we will learn the basic of limits and continuity of a function. Thank you.